Hello everyone. Uh, Today I am going to discuss how to create advanced regression model. In previous one of my previous lesson, I already shown how to create regression model, but here is the advanced one. And here I will also take the same example, a house price prediction, but a different data set, uh, kind of real world data set. And not only that, here I will compare, I will create uh, two, three couple of models, and I'll compare the performance of the model, and then I choose the best one. So let's have a look. So here you can see, I have created a notebook, Jupyter notebook, and here couple of notebook block or cell there, and each cell contains a specific task, and one by one I'll explain. I'll try to make it easy as possible. So this is the import part and some constant declaration. So here you can see, here I have used main pandas, numpy, matplotlib, seaborn, and we have used scikit-learn dataset. Uh, we going to use the California housing dataset. So let me show you some basic introduction. So what is regression? Just reminder. Regression is a type of supervised machine learning where the model learn to predict a continuous numeric value. We already discussed it. Just for reminder, I'm just repeating. So in this lab, as I said, the target is a mid house value, median house value prediction. Okay, so the model learn from the features such as median income, average rooms, average occupancy, latitude, longitude, and other housing related values. Okay, so goal is to predict the house price from these input features. So what actually you will do, that is read the data set, visualize it, train the model, evaluate the performance, and save the trend pattern. And the input part I already just shown you that I have used pandas for tabular data handling, numpy for numerical operations, matplotlib and seaborn for plotting related, scikit-learn for machine learning algorithm and pre-processing, and Joblib is for saving the trained model so that you can import this model and use it. And you have seen I have set a constant value like this random state. What is the use of it? Is a fix the random state. It makes the result reproducible. That means if you run again, your data set will be same. Actually, value does not matter. Uh, there is a history behind this why you said 42. I'm not going to discuss here, but it is not because it is not important. But uh, every time we use this value. The model directory where our model will save. Now, next part is loading a data set. Let's have a look in the code. So input part I already run because as it takes longer time, That's why I am not repeating this part. I already run it. Now I start with the data loading. So I am going to use here the California housing dataset, and I will print the shape, housing features, name. I mean all the it will list all the features, okay, and our target column as well, the mid house value. So all the basic uh, information of the data it will print. So step will print up like this. 9 column is present and around 20k rows is present in the dataset. And feature is made in INC, I mean median income, house age, average rooms, average number of bedrooms, population, how many people live over there, uh, average occupy, latitude, longitude of the house, and target value is the median house value. Okay, so this is the you can see the data set, and now next part is exploratory data analysis. You already know because as I in my if you watch my um, tutorial, previous tutorial, I already explained what is exploratory data analysis. Actually, this step answer below question like what kind of data do we have? Are there are there any missing values? Are there any unusual values? Any duplicate values? Okay, which feature seems important? Because in dataset normally in real life lots of unnecessary columns present. So if we not remove those column, okay, it will create the noise. So our ML model not going to be perfect. That's why very important part. Main this exploratory analysis. So first let's understand the df info actually show the column type and check if any values are missing. Actually, from here you can identify what are the string data or numeric column are present over there. Because sometimes first regression level model it works only the numeric values, cannot work with the string values. So then we need to convert those values to string one. Sorry, string to numeric. That's why this is very important. The description is actually basic statistics, mean max. This. From here you can identify is any outlier is present or not. Okay, just can see mean and max. This is mean and max is 15. Very not very high, high but not it is not affect too much. So you can see the and have this simple idea is any big outlier is present or not. And Here we are trying to find out the is any missing value in each column. You can see this script, this line actually doing this job. And in our data set, no missing value is present. Okay, because in this print statement that we have applied the if else logic. If any missing value present, then it will print those. Otherwise, it will say print no, none. Data is complete. Now draw a histogram for each column to see how the values are spread. From this diagram also we can identify the outliers. I'm not explaining the code because I already discussed in previous session how to plot the histogram. So here you can see all the columns histogram is present. This is looks okay, this looks okay, but here you can see for average room, every room outlier is present and skew to right one. Same for average bedrooms, same for population, same for average occupiers. Okay, these data are going to populate. This looks okay, but here you can see in mid house well at 5 is this outlier, right? Because these values like looks like normal, but it looks like bell curve. But here you can see suddenly high value. So histogram the notebook histogram is this helps us to detect a skewness, outliers, unusual shapes, and non-normal distribution. Okay. So from the above diagram, what was the observation? Already said, but again I'm just repeating. The target column, which is house price, has some value that are capped at the top. Yes, here this is a target column, right? This is a capped. This means that the data is not perfect, and we must be careful while training the model. So obviously, we need to handle those skewness. Now we uh, create the correlation matrix. How each column correlate to other. This is a correlation matrix, and here you can see if you carefully observe. This color means high and this color means low relation, very low relation. So here you can see 0.69. So mid house value and median income very strongly related to mid house value, median house value. Okay, that means smaller change in the income, it will affect the value. Now we are plot each location on a map and color it with the house price. It's a scatter plot. I mean, here we are just plot the longitude and latitude. Using this scatter plot, I need to identify the how the location actually affect the median house price, the price of the house. Okay, geographical distribution of the house values. Like if the coastal distance of the house from the coastal distance is affected or not, like that. So in this notebook, use the latitude and longitude to map house values. This reveals the location matters strongly, especially the coastal regions. So EDA is very important because good models come from good understanding. So EDA helps avoid blind training on bad data. And next part is data cleaning. Actually, real data sets often have invalid values, capped values I have shown you, outliers, and inconsistent scales. Okay. If we do not clean the data or transform the data, the model may learn from bad pattern, right? Let's have a look. So, in the previous observation, we have seen the price value, median price value as a kept one. Okay. So, so now we clean the data so we the model learn from the better examples. Okay. Now we clean the data so the model can learn from the better example. So we make two important decisions here. So we remove rows where the house price is kept at the top because these values are not true real price. And second, we reduce the impact of the extreme values in some features so that one very unusual value does not bad affect the model. So that means we have to decide whether we remove or not, and it also not affect the model performance. So in some place we remove the row, in some place we keep the value, but we just modify those values. Let's have a look how did this. So as I shown before that, there is a cap in the median house value. So to find this cap value row, we have used this logic like if the value we just keep the value if the if 5 below 5 and remove the other one. So now our clean data is first step cleaning is completed. Next is I already shown you the in the our plot this average rooms, average bedrooms, population, average occupation. So these are the right skew. The extreme skewness is present. We have to handle this. For that, what we have to done that is um will apply the quantile logic. if you watch my previous lesson, where I have already discussed how to create a quantile for dataset. Actually, we um, categorize or create separate sort of data. You can see in the quantile function we passing 0.01, 0.99. Let let me discuss. So to clipping the extreme outlier for these columns, okay, we are using quantile. So why? So outlier values can distort the model training. So clipping reduce their impact while keeping the row in a dataset, right? So as you have, so I have shown you that from the quantile function, we have passed 0.01 and 0.99. So these are the lower and upper percentile used for clipping. So they define the acceptable range of the values. Okay. I'm not discussing here the what is quantile because already discussed. Otherwise, this tutorial will be lengthy. So that's why. So then, if we apply this logic, it will uh, force the value to range between this value. Okay. Now, next is a feature engineering. These steps is a new features that may help the models make better predictions. In the previous lesson, I have not shown you the creation new features, but create the model on top of the existing column. But here, I'm going to show you the uh, to make the model better prediction. We have to sometimes we have to create more columns, extra columns to help the model to calculate like bedrooms per room, room per person, distance to coast. Okay, because these rows are very vital. If the bedroom in number of bedroom increase, obviously your cost house will be high. Okay, distance also very important thing. And room per person actually sometimes tell that how spacious your room, right? One bedroom, two bedroom, okay, like that. Three bedroom, like this. So these new features may carry more useful information. So that's why we're going to create these new features. So first here actually taking the uh, coastal three big coastal cities. This is the latitude and longitude of the three: Los Angeles, San Francisco, San Diego. Okay. Now within the engineering features, engineering method, yes, adding the new columns, calculating and new for adding the new columns value. The bedroom per room, how to calculate? average bedroom by average room. Rooms per person, average room by average occupancy. And how we calculate the distance? Yeah, from the from these latitude longitude, and each house has its own latitude longitude. Just find the distance. The same thing here. Okay, and finally calculate the distance to coast column. And here you can see um, also a new columns are created, and this status mean max value. Not outlier, no outlier is there. So data is okay. Next step is a train and test split. It's a normal one, and also take care of the leakage prevention. So this is important because we want to test the model on new data that is has not seen before. Suppose if you test the data or train the data or the same data set you test the data, in that point that leakage will happen. So this need to be handled carefully. So that's why train and test split is very important on the same data set. So here is the case size is 0.2 by 20%, and remaining is the our train one. And you can see we have used the random set. I mean, if you train with this again, repeat the if we repeat the step, it will retain the same data for the data set for the train and test. It should not. Uh, I mean, it will be new data set. Because to for evolution point we have sometimes we have to iterate this process within the data model with the same data set after modifying the weight. Okay, that's why. Now we is scale all the numbers to a similar rate so that model is not biased towards bigger number. We already discussed in the previous lesson that if we go to the data set, different column has different type of data set. You can see this is the value 8, but house age 41, 42 very big. Okay, here population side 322, 2401. Okay, so different type of data value is present. So to before train to make it in the same scale like from 0 to 1. Okay, it is very important. So we do the same thing using this function column transformer column transformer. And now in here we just create the base model from the different ML model. First, a linear regression, ridge. This is a linear regression plus linear combination of both. Then the random forest, and the last one the gradient boosting. So we're going to create a four model and compare the performance. Okay, now we are create the new dataset like speed dataset into 5 parts to test each model fairly. Let's one just hold on. Explain the things. Yes. So we have created here k-fold function to split the dataset into 5 different datasets. So what is this? So here you can n space. So is 5. That means the data is split into the 5 folds. Then shuffle true. The rows are shuffled before splitting. Random step is the same thing. Each time give the same data. That's why. So why we use? Actually, it gives a more reliable estimate of model performance than a single train attribute. Actually, we're going to train the and test the model 5 times with 5 different data sets. Now we can see we each looking into the each model, and here you can see we are combining the scaling and model. Scaling preprocessor means we are standardizing the scaling the value. I mean, in the same pipeline, in this pipeline, it will learn this one and then get the model. Okay, and cross value score. So it will train and test the data set, and it will return the scores so that we can uh, verify how good our model is. Let me explain what is this. You can see uh, scores. Actually, from the scores we are taking the mean, standard deviation. So what is the mean? Turn the negative score back into a normal positive error number. And score standard deviation, how error the changes across the 5 tests. I'm not repeating this. What is standard deviation mean? You already know, because I already discussed in details in in one of my previous uh, lecture. And at last we just sorting the data. I mean this pipeline data set we have just created the list of the model information by the by sorting the RMSE mean, root mean, square error mean, root mean, square error mean. Okay, and it shows that random forest is top, then gradient boosting, then linear. It should be, because random forest is more advanced one. So a lower error value is better, but we should also think about the speed and stability. Okay, a model that is slightly better but much slower to train may not be the best choice in real project. Yeah, definitely. So we want a model that is both accurate and practical. So from this table we have to decide this. But here you can see compared to random forest, we can gradient boosting because you can see speed time is smaller and this value is not too much different, small difference, right? Let's go to the next part. So hyperparameter parameter tuning. Okay. So here we can see we set the hyperparameter for the all the models, not all the models. Here only take as the random forest, gradient boosting, and ridge. Because we have from table linear regression is uh, actually we can we cannot we have I mean not that we cannot use this, but we don't need to hyperparameter tuning because if for linear regression don't have such type of like hyperparameter. Okay, so that's why we can we have not use the linear regression here, but we don't I mean what trying to say that don't remove this linear regression model from our uh, journey in this tutorial. Okay, still it will with us. So let me describe what is hyperparameter tuning. So even after choosing the model, we can often improve it by tuning its hyperparameter. So hyperparameter are setting that control the learning process such as tree depth, number of trees, learning rate, regularization strength. So here you can see we use a randomized search CV. This method actually tries to random combination of parameters and evaluate them using cross validation. The important parameter is like n iter. It was 15. That means the number of random combination to try. 15 is a practical compromise between speed and search quality standard value. Okay, and CB also uses same cross validation strategy already defined. As in the K4, we already defined the CB. The CB one is, let me CB. What is the CB? Sorry, yeah, this CB. Same data set I have used here as well. Okay, yeah, and scoring is a negative root mean square error. This means the model is evaluated using RMSE root mean square error. The negative sign used to because skill-learn has to maximize scores, while RMSE is a loss metric that should be minimized. And randomizer is 42 as I already defined. And let me show you another thing, that is what is the meaning of the hyperparameters. Okay. So as I've said, that why not linear regression used in here? You can see here linear regression not present because we don't have hyperparameter. That's why hyperparameter tuning box linear regression not present. Sorry. Yeah. Then reach. If we go to the reach, here we have consider alpha. What is alpha? Let me, yeah. So alpha controls the regularization strain. Higher alpha gives the stronger penalty to the larger coefficient, and this reduces the overfitting. Okay. To reduce the overfitting, actually, we use the alpha. Alpha equals to 0 means no regularization. Actually, reach means a linear plus regularization. First, you apply the linear regression, then apply the regularization. But if we put 0, then it acts as a linear regression model only. But if we put 1 and our other value, then it will control the how penalty or how big your coefficient. And for random forest regression, the hyperparameter is n estimator. What is it? The number of decision trees actually. Standard value is 200. So more trees usually improve the performance but increase the training time. Then a random state is a fixed randomness, and n is equal to -1 means use all the CPU cores. Actually control the training process so that it parallelly training process happens. So it will take smaller time. Then gradient booster build trees sequentially. Each tree is correct and mistake of the previous one, and often uh, powerful on structured and tabular data. So hyperparameter is here the tree depth, number of trees, landing rate, regularization. This is actually important parameter. And I'll in the next video I'll uh, teach you the in details the hyperparameter things, because I have not shown you the random forest, gradient boosting, read. Just in this video, I show you how to compare each model and train your model, okay, and uh, choose the best model. Now, search the treat. What is this? Actually, only use the train data here. The data is saved for later. And finally, the base version of the model ready to test and save. On the above parameter, which is base, it will be saved in the base pipeline. because it is this function return the base estimator parameter. And last one, the evaluation on the held out test set. In this step, here we check how well the final model performs on data it has never seen before. That means here we're going to test our model with a real data set or new data set. These are new data set. Now, I mean, as we have before shown you we have already kept separately the train and test data set. We train but not test yet. In this step, we're going to test it. And we just pass a test data set. Here we are not passing the y because we have to calculate the y, predict the y. And now I'm comparing the original output with the predicted output and calculating the RMSE, ME, and R2. Okay, and this means all the values. And also we're calculating the calculating and plotting the values. I mean different plots to understand properly. Is the actual or predicted. Okay, and now this the value is like this. This looks like normal. This plot also scatter plot also looks normal. So also we check the which columns matter most on the model prediction. For this we have to just uh, already our base pipeline return the features importance parameter, and if we print this we can see, and we have plot those values which affect most. We already shown we have seen in the our correlation matrix the mid median income is highly related to the our target value. Now just we are saving our model in local directory so that we can just import it and use it. Okay, and just I can double check after our saving our model. Just here from the path we load the model, and again just use to predict the value, and we got the result. So this is the actual aim of this block. Now our model is ready. In next tutorial, I will explain more in more details. Just before in this tutorial, I just remember one thing. What is RMSE? RMSE root mean square error. The mean absolute error. But what is RMSE? RMSE measures the average size of the prediction error. It is sensitive to large error because it squares the error before averaging. Lower RMSE means model better model performance. Then ME measures the average absolute difference between actual and predicted values. It is easier to interpret than RMSE because it is not limited by extreme errors. Lower RME also indicates better performance. R square tell us the which of the variation in the target is explained by the model. Closer to the one is better. One means perfect information, zero means the model performs no better than a very simple baseline. Okay? And what is residual analysis? These are the difference between actual values and predicted values. Okay. And why residual matter? It helps us to see whether the model makes systematic mistake. So that's why you have as I shown in the plot residual versus prediction, residual distribution as well. If the model is good, the residual should be randomly distributed and centered near zero. So that's all for today. Thank you.